Dear audience, we are going to learn the conjugate matrix, Hermetian matrix, Skew Hermetian matrix. So what's the conjugate matrix? If a matrix is given, then changing the complex entry as a conjugate complex, then we'll have a matrix, and then the matrix obtained in this way is known as a conjugate matrix. In this example here, we'll find that A equals -2, 2 minus 3i, 3 plus 2i, and 3. And the conjugate of it will be denoted by the A verb. And we have to change the complex entry here. The complex entry is 2 minus 3i and 3 plus 2i. So write down the conjugate complex of these entries is the 2 plus 3i, and the conjugate complex of 3 plus 2i is the 3 minus 2i, and remaining the and all other entries will remain the same. That means they won't be changed. Then this matrix is known as the conjugate matrix of the given matrix. Hermetian matrix. A square matrix A is said to be the Hermetian matrix if the transpose of the conjugate of the given matrix equals A is known as the Hermetian matrix. Again, I repeat it. A square matrix A is said to be the Hermetian matrix if the transpose of the conjugate of the given matrix A equals A. For an example, here A equals 2, 1 minus I, 1 plus I, and 3 is a Hermetian matrix. Why Hermetian matrix? Because first of all, we write down the conjugate matrix of it. We take the conjugate matrix of the given matrix A. So conjugate matrix means we have to change the complex entry. That means we have to write down the conjugate complex entry of the given complex entries. Here the complex entries is 1 minus I and 1 plus I. So the conjugate complex of 1 minus I is the 1 plus I. And the conjugate complex of 1 plus I is the 1 minus I. And putting all other entries without changing, we find that 2, 1 plus I, 1 minus I, 3. So that is the conjugate matrix of the given matrix. But again, we have to take the transpose of it. Transpose means we have to make the first row as a first column and second row as a second column. Then we'll have 2. Here the first row is 2, 1 plus I. So we make it first column 2, 1 plus I. And the second row is 1 minus I, 3. So we make it second column 1 minus I, 3. And it is equal to the given matrix A. Since the transpose of conjugate of the given matrix A equals A, so we can say that A is the Hermetian matrix. So we can write that is the Hermetian matrix. Now we are going to learn about the skew Hermetian matrix. What is the skew Hermetian matrix? A square matrix A is said to be a skew Hermetian matrix if the transpose of the conjugate of the given matrix A equals minus A. For an example, here another matrix A equals 0, 5 plus I, minus 5 plus I, 3i is a given matrix. Now, we have to show that it is the skew Hermetian matrix. First of all, we take the conjugate matrix. Conjugate matrix, we have to change the complex entries here. That means we have to write down the conjugate complex of the given complex entries. Here the complex entries is 5 plus I. So the conjugate entry of it will be the 5 minus I. Similarly, the conjugate complex of minus 5 plus I will be the minus 5 minus I. And other entry will remain same. And taking the transpose of this matrix, we'll find 0, minus 5, minus I, 5I, minus 3I. And taking minus as a common, then we'll find that minus 0, 5 plus I, minus 5I, minus 5 plus I, and 3I. And it is actually the given matrix A. So we can write here A. So we find that the transpose of conjugate of the given matrix A equals minus A. So we can say that the given matrix A is a skew Hermetian matrix. Dear audience, I hope that you could understand the today's lesson. Again, I will come along with a new video tutorial. Till then, goodbye.